So friends, till now we have understood that the electric field will be varying with position. And what is the relation between them? The magnitude of electric field is inversely proportional to r square. Now the point is, we want to plot a graph between the variation of electric field strength and position of the test charge. So if you see, we'll start with the point charge, and by convention, whatever electric field is towards the right will be taken as positive, and whatever electric field is towards the left will be taken as negative. And the electric field strength, we will plot it on y-axis, and the position will be plotted on x-axis. And you will assume that the source charge is placed at the origin of the x and y axis. Now from here, if you put the test charge at infinity, what would be the electric field? It would be 0. Now if you bring the test charge very near to source charge, not on the source charge, remember, on the source charge electric field is not defined. So when you bring the test charge very near to source charge, what would be the electric field? Definitely the R will be tending to 0, so electric field would be infinity. So the graph will be starting parallel to y-axis, and it will move down like this, and then it will be parallel to x-axis. So this kind of hyperbola you are seeing is in the case where E is inversely proportional to r square. So you can see the graph is starting from parallel from y-axis, and it is now parallel to x-axis, and this kind of hyperbola you are seeing where E is inversely proportional to r square. Now this is on the first quadrant. When you similarly take the left hand side electric field into consideration, definitely it is negative. So now the graph will start from negative y-axis parallel to it and will move down in this direction parallel to x-axis, because the test charge, when you put it on infinity on this side, will have the 0 electric field, and when you bring it very near to source charge, the left side, then the electric field would be infinite but on the negative direction. So you can see on the first and third quadrant the graph is there for a positive source charge. Now similar exercise can be done for a source charge which is negative in nature. Yes, in this case again the convention remains same. Now in the negative source charge, if you see, the electric field on the right hand side will be on this side, that means it would be negative, and the electric field on this side is moving along that side, that is, it is taken as positive by convention. So how the graph will appear? Let's put a test charge and understand. So if you make it the x and y axis, you will understand that now the electric field which is on that side will be on the left side, that is negative. So it will start from here and then it will move up to that point. So still the relation of magnitude of electric field with position is same. E is inversely proportional to r square, but the quadrants have changed. And if you see on the left hand side, then you will understand that the same kind of graph is there, but now the electric field is towards right side, that means it is positive, so the graph will be on the upper quadrant. So in the source charge, when it was positive, the graph was on first and third quadrant. In this case, when the negative source charge is there, the graph is in second and fourth quadrant. I hope you have understood this very easily. Now let's assume another case where we have two positive equal charges. In that case, how will be the graph? In that case, what you should do is you should draw a line and put two vertical lines. At one intersection, put a positive charge plus q, and at that other intersection, put a positive charge plus q. Now, first let's talk about the side, that is where the test charge can be put across on that side. Here in that case, you will understand that this positive source charge will have a very less effect on the test charge, because the q which is near to test charge will be having a higher impact. So the graph on that region will be similar to a positive source charge there. And similarly, if you put the test charge on this side, then the impact of this source charge will be greater, and the graph would be something like this. So this and that graph we are comfortable. Now let's talk about what happens in between them. Definitely these two are equal positive charges. In between we will get a neutral point. So at the point in exactly between the two charges, you will get 0 electric field. What? At the side on the right side. So if you move to right side from the middle point, you will understand that the charge, this q, is dominant, and the dominant charge will have electric field on the left side, that is negative quadrant. So graph will be like this, starting from the midpoint to parallel to negative y-axis. And on the side, that is between the midpoint and this charge, you will understand that the graph will start from y-axis and will be till this point. So these kind of things are very important for you to understand that how do we arrive at that calculation. We are not applying exact mathematics, we are still relying on the relation E inversely proportional to R square. And same kind of graph would be there, but just the reverse of it if you use this negative source charge. As you can see, this would be the graph, a very similar kind, right? But the polarity has been changed. So I hope you have understood the variation of electric field strength with position with the help of these graphs. In the future coming lectures, we will be seeing and dealing with more of such kind of graphs and numericals. Let's proceed with superposition principle. So friends, till now we have understood that what is the magnitude of electric field strength at any given point due to a source charge. But what if there are more than... So friends, till now we have understood that what is the magnitude of electric field strength at any given point due to a source charge. But what if there are more than one source charge? In that case, what will happen? Yes, that is the level we have to understand. And that we can easily understand by the help of superposition principle. In superposition principle, we are going to apply a similar kind of learning what we did for the case of multiple charges applying force on a given charge. Yes, and let's start with the understanding. This is a test charge in front of you, which is Q0, a very small charge, right? And we have a charge Q1, which is placed at a distance. So yes, and let's start with the understanding. This is a test charge in front of you, which is Q0, a very small charge, right? And we have a charge Q1, which is placed at a distance R1 from the Q0 charge, and it is applying electric field in this direction. Similarly, we have another charge Q2. So there is another source charge at a distance R2, which is applying electric field E2. And let's make the situation more complex, where we add one more charge Q3 at a distance R3, and it is applying electric field in this direction. Definitely what will happen? Any given point cannot have electric fields in three different directions. At any given point, the electric field will be one. So there will be a net electric field which is acting on this charge, that is point P, or at this charge, and that's what we want to find. And in this, superposition principle will help us. Let's see what the superposition principle says. Now, as per superposition principle, you can see at any charge or any test charge, when there are one or more than one charges which are applying electric field simultaneously, the net electric field which is acting on that test charge or at any given point is the vectorial sum of all the electric fields. Let's see as per the definition. Electric field on any charge due to number of other charges is the vector sum of all the electric fields on that charge due to other charges taken at a time. And this term is known as principle of superposition, right? Now, how can you denote these things? That's important because this will come in your school exam as well. So first of all, as per the definition, the net electric field which is acting at any given point will be the summation of vectorial additions which can be represented like this, right? Now, in this case, first of all, when you talk about the case we have just understood, so E1 was given by K Q1 upon R1 square R1 cap. E2 is given by K Q2 R2 square R2 cap, and E3 is given by K Q3 R3 square R3 square R3 cap. Now these are the three vectors which were acting on that particular point, and if I want to do the vector addition, what I can do is E net is going to be K Q Q1 R1 square R1 cap plus K Q2 R2 square R2 cap plus K Q3 R3 square R3 cap, right? Now, how can we add on these? Just take the K part common. If you can do that, you will get E net K, or I can say 1 upon 4 pi epsilon naught Q1 R1 square R1 cap plus Q2 R2 square R2 cap plus Q3 upon R3 square R3 cap. Now, rather than writing this large term where I have to write this much explanation, what I can do, I can apply a simplified method. What I can do is, I can simply write E net is equals to 1 upon 4 pi epsilon naught Qi Ri square Ri cap. This is an important observation and I want you guys to remember it. And one more thing, this should have this symbol where I equals to 1 to n. Now what is this? I have done a summation where I have taken this portion as common and I'm just running it in loops where I can start with I equals to 1, so it would be Q1 by R1 R1 cap, Q1 by R1 square R1 cap, then the summation sign, that means plus. Now I becomes 2, in that case Q2 by R2 square R2 cap, and then Q3 by R3 square R3 cap, and so on till the nth number. So this is a simplified representation of net electric field which is going on. But friends, just remember, this is a mathematical approach. When you solve with the help of numericals, it is going to have a very different kind of approach. So let's solve a question with the help of superposition principle and understand how it can be applied easily. Now, here, as per the question, we have to calculate the electric field strength acting at point P due to mentioned two charges in the diagram. And there are two charges Q and Q, one at origin, one at 3, 0. And the P point is located at 3, 4. We have to find the electric field due to both of these. Simply, it's an application of superposition principle. Let's start with the solution. Now, before we proceed with the solution, the first important thing is that let's take this would be R1 and this would be R2, right? That is distance between origin and point P would be R1, and between this point, let's assume that this point is M. So between M and P is R2. Now, we have to know the vectorial values of, that is the value of R1 vector and R2 vector. So R1 vector can simply be written as 3 I cap plus 4 j cap. It's easy to understand. And second, R2 vector would be simply 4 j cap. I hope you have understood this one. Now, the point is, where is the electric field due to both of these going towards? So if you try to understand that, let me plot that for you. Electric field due to this first charge, if this is the first charge, electric field will be in this direction due to the first charge. And due to this charge, the electric field will certainly be in this direction. So let me write that for you. This being the first charge, this being the second charge, this is E1, this is E2 vectorial, right? Now, whatever be the angle between them, right now I don't have to worry about it because I am solving it into vectorial form, and easily I will find the solution. So, what should be the formula for E1? As per the formula we should write 1 by 4 pi epsilon naught Q upon the distance, that is R1Q, R1 vector, right? And similarly, if you just write down the values here, you will get E1 vector is equals to 1 upon 4 pi epsilon naught Q upon the magnitude of R1. If you just write the magnitude of R1 here, you will get under root of 3 square plus 4 square, that would be 5. And what is the magnitude of R2 vector? You will get, it is simply 4. So you will get 5Q into the R1 vector, that is equals to 3I cap plus 4J cap. This is the first equation which we have found. This is the value of E1. And let's talk about the value of E2. So E2 vector would be equal to 1 upon 4 pi epsilon naught Q upon R2Q into R2 vector. Again, the same notation I have used. Let's put down the values. You will get 1 upon 4 pi epsilon naught Q upon the magnitude of R2 is 4 units. So here it is 4Q into 4J cap. Solving this, simply the 4 and 4 can get cancelled. It is 1 upon 4 pi epsilon naught Q upon 16 J cap. So this is the value of E2 vector. Let's take this as notation 2. So I have two values of electric fields. This is E1, this is E2, and they are in I and J cap. I can simply add the components along I can be added and the components along J can be added. So let's add these. We will get the net electric field as per superposition principle would be E1 plus E2. I'm just taking 1 upon 4 pi epsilon naught as common. Also Q can be taken out as common. What I am left with is 3i plus 4j divided by 125, that is 5q, plus 1 by 16 j cap. So this is net, right? Now, if you want to just simplify the representation, you can write E net is equals to 1 upon 4 pi epsilon naught q, that will be common. What we can write is 3 upon 125 I cap plus 189 upon 2000 J cap. This is the net electric field I am talking about, and I hope you have understood this very clearly. So a simple application of identifying that what is the value of electric field strength there and due to the two charges, and thus simply adding them. Another approach which could have been here is like we could have found the magnitude of E1 and E2, and certainly this is the 90 degree, this would be 5, this is 4, this is 3. So this angle would be 37 degrees. This will also be 37. You could have found E1 and E2, and this is the angle between them. Then you can do the vectorial sum, that is under root of E1 square plus E2 square plus 2E1 E2 cos 37. But in that case, again you need to define the alpha, where the net electric field will be somewhere in between them, and in that case definitely you will end up that this is the horizontal, this is the alpha, and you will have to define alpha. So again you will get the same here as well. Better to do the IJK part in these kind of cases. I hope you have understood the superposition principle easily. Now let's move on to some of the numericals. So friends, by now we have understood the details of electric field and how we can relate the electric field with the formula of KQ upon R square or F by Q. Now let's take some numericals so that we can apply what we have learned here. Starting from the first question, when you see the question says there are 2 point charges which are separated by a distance of 10 centimeter. One has a charge of minus 25 microcoulomb and the other has a charge of plus 50 microcoulomb. Now there are parts to it. The first one is determine the direction and the magnitude of electric field at a point P. As you can see in this diagram, these are the two charges we were talking about, and this is the point P. The point P is situated at a distance of 2 centimeter from the negative charge. So from minus 25 microcoulomb, this distance is 2 centimeter. So rest would be 8, obviously. Now the second part is if an electron is placed at rest at P and then released, what will be its initial acceleration? This is what we have to find. So there are two parts. Let's start with the solution for first part. Now taking the first part, the first is this is charge 1, this is charge 2. Certainly this charge will apply some electric field at point P. As far as what we have learned, the electric field at point P due to this first charge would be in this direction. So this would be E1. Similarly, if this is the charge and this is the test charge, electric field due to 50 microcoulomb will also be in this direction, that is represented as E2, right? Now, both of them in same direction, and by the application of superposition principle, we can easily find the net electric field which is So let's start with the calculation of the values. E1 by magnitude can be written as 1 upon 4 pi epsilon naught 25 into 10 to power minus 6 divided by the distance, that is 2 into 10 to power minus 2 whole square. Remember one thing, this minus charge you will not be writing here as I am writing the magnitude only. The second thing is I have already taken into consideration the directions, right? Now from here, if you solve this one, that would be 5.625 into 10 to power 8 Newton per coulomb. This is the first value, right? Now let's talk about value E2. So this would be 1 upon 4 pi epsilon naught 50 microcoulomb, right? Divided by the distance, that is 8 into 10 to power minus 2 whole square. As you can see, I am converting each and every CGS value into SI unit. So it is important for you to note that, right? Always practice the same in each and every step. Now, when you calculate this value, you will be getting E2 to be 0.703 into 10 to power 8 Newton per coulomb approximate. So now you have both the electric fields. If you talk about E net, on vectorial note, this can be written as E1 vector plus E2 vector, right? Now I have two options. Either I can just see that both the electric fields are on the left side or towards the negative charge, so I can simply add them, or I can set an X and Y frame and put the value of minus I cap and minus I cap here, and then they can be added. So both the ways, the addition will be there, the magnitude will be added because both the vectors are in same direction. So when you solve this, you get E net. I'm just talking about the magnitude here, and then I will write that the direction is towards the minus 25 microcoulomb charge. So that would be 5.625 into 10 to power 8 plus 0.703 into 10 to power 8. This on solution will give you 6.328 into 10 to power 8 Newton per coulomb. This is the net electric field, and remember one thing, it is directed towards minus 25 microcoulomb charge and along the line running the two charges. So we have given the magnitude as well as the direction here. So this is the final answer. I hope you have understood this one. Now the point is the second part of the question. The first part, we have found the net electric field which is acting at point P. The second is, what about if I put an electron here? If you can see here, if an electron of this mass is placed at rest at P, then what will be its initial acceleration? So in order to find the acceleration, we first should know what is the force which is acting on it. So solution of second part, we have to find the acceleration of electron, and that would be given by force on electron divided by the mass. Force on electron can be simply represented by Q of electron into the net electric field which is existing there. And if you see, this is vectorial form, so you can write like this, divided by the mass of electron. Obviously, the electric field is towards the minus 25 microcoulomb charge, so the force on electron will also be towards that direction. Can you say so? No, it's different. As we have studied, electron is a negatively charged particle, and if you place in a uniform electric field or an electric field, it will move opposite to it. So if you find that AE, obviously this would be vectorial if I am mentioning it, this would be minus of E into E net divided by mass of electron. What is E? E is the charge of electron, that is 1.6 into 10 to the power minus 19. Mass of electron is 9.1 into 10 to the power minus 31 kg. So let's put down the values. So first of all, I am just finding the magnitude, 1.6 into 10 to the power minus 19 into 6.328 into 10 to the power 8 divided by 9.1 into 10 to the power minus 31. When you solve this, will be 1.126 into 10 to the power 20 meter per second square. Now this is the acceleration and it is opposite to electric field. Remember that? So that final direction here would be towards plus 50 microcoulomb charge, right, as opposite to the electric field. So this is the final answer. So we have found that what is the net electric field working at that point, and also what is the acceleration of the electron. Now it was pretty simple application of electric field and a basic understanding that electron, a negative charge, will move opposite to that of electric in which it is placed. Now let's take the next question, that is question number 2. Now in this question we have to find a point charge q is placed at x equals to 0. The electric field vector at x equals to L is E. So you can see in this diagram there is a charge which is placed at origin and there is a point here P which is lying at a distance L, right? And there is an electric field E which exists there due to this charge. When another charge 4q is placed at x equals to 2L, so a new charge 4q was placed at a position of 2L from the origin. What is the new electric field vector at x equals to L? So we have to find the net electric field here at this point. So this is the point P, right? The distance from here to here is given as L, and certainly from here to here is again L. Obviously both the charges will apply electric field here. Again it's in simple application of superposition principle. So let's start the solution of same. So first of all we have to find the magnitude of E1. If you first see the direction, it's already given that E1 is along this direction and E is along this direction. This electric field is due to this charge and this electric field is due to 4q. So E1 will be represented as 1 upon 4 pi epsilon naught. Charge is 4q divided by L square. This is the first equation, right? And what is the value of E? That is also important. So E is the electric field which is applied by Q. I will write 1 upon 4 pi epsilon naught Q divided by L square. This is the second. Now, what is the net electric field which is acting at P? If you want to find the net electric field, obviously E net can be represented as the vectorial sum. And if you see actually that both of them are in opposite direction, right? In this case, what you will do, if you just want to find the magnitude, as in the question it is said that what is the new electric field vector at x equals to L. So we have to find the answer in terms of E, right? So if you find here, we will write E1. This is the value. So 1 upon 4 pi epsilon naught 4q upon L square minus 1 upon 4 pi epsilon naught q upon L square. Certainly this value would be positive. That means E1 is of bigger magnitude. So in this diagram, what we have seen, I will consider this side as a positive direction and this side as a negative direction, right? Okay, so if the net electric field will be lying on the E1. Why along the E1? Because this being the bigger magnitude, the net electric field will be lying along this. Only for this question I am taking the convention. Towards left it's positive, towards right it is negative. So from here I will certainly write E net is equals to 1 upon 4 pi epsilon naught 3q upon L square. This is the value of E net, right? This is the third equation. Now if you just write that what is the value of E net divided by E, you will get that to be 1 by 4 pi epsilon naught 3q by L square. This whole should be divided by 1 upon 4 pi epsilon naught q by L square, and solution would be 3. Here you can see an important thing. This is just the magnitude of electric field. So you will say that the net electric field is 3 times to that of the original electric field which was there. But if you see the vectorial form, it is important for you to understand. If you see E net, in that case this is vectorial. So I would write 1 upon 4 pi epsilon naught 3q by L square, as I have taken E1 direction to be positive and the net electric field will also be along E1. But for E it would be minus 1 upon 4 pi epsilon naught q upon L square, and this value would be minus. So if you see the net vectorial form, you will write E net vector will be equal to minus of 3 E vector, and this is what the question was asking. So when you talk in terms of magnitude, it's simply 3. But when you talk in terms of vectorial sum, then in the case of vectors, the net electric field here is going opposite to that of the original E. That's why it is the opposite side, and definitely the magnitude is 3 times. I hope you have understood this question very well. Now it's time to take another question. Now let's take our next question. Here, in this question you see there are 3 charges which are placed at the vertices of an isosceles right-angled triangle with charges plus q minus q at the vertices with acute angles and a charge plus 2q at the vertex with right angle. So you can see here in this arrangement where this is L, this is L, this is minus q, q at the acute angles and 2q at the 90-degree portion, right? Now, determine which of the numbered vectors coincide in the direction with the field produced by these charges at a point that is in the middle of the hypotenuse. So we are talking about this point, friends. Let's consider this as point P. We want to find the electric field due to these. Also, we will find the net electric field here. So, starting with the very first one, if you just want to find that what is the electric field due to plus q charge on this charge. So, this is a positive charge. Certainly, the electric field will be in this direction, right? And this is the negative charge. It will try to attract the test charge towards itself. So, again, the electric field due to minus q will also be in this direction. And if you want to find the electric field due to this plus 2q charge on here, you will find that the electric field will be in this direction. Why this is thicker? Because definitely it's a bigger charge, right? So let me write that for you. Electric field due to plus q charge, electric field due to minus q charge, and this is electric field due to plus 2q charge, right? And certainly they will be perpendicular to each other. That means there are 3 electric fields which are working at point P, this, and this, right? Where electric field due to plus q and minus q is along same line, so they can be added. Now, if you just want to find a summary, I'll give you a summary. Let's start with the solution. Here is the summary for you, that this is L, this is L. What length is it? It would be L by root 2. Similarly, this distance will also be L by root 2. So when you see at these 2 electric fields, the magnitude of charge which is causing the electric field is same. The distance is also same, both L by root 2, L by root 2. That means the magnitude of these 2 electric fields would be same, right? Considering then, if you understand, this is same and this is also. So if you just put the values E of plus Q can be written as 1 upon 4 pi epsilon naught Q upon L by root 2 whole square. This can be simplified as 1 upon 4 pi epsilon naught 2Q upon L square. This is equation 1. Similarly, if you talk about E minus Q, that would be 1 upon 4 pi epsilon naught. Everything would be same. So it will come to be 2Q upon L square. This is the second. Now both are in the same direction, and if you want talk about E plus 2Q, that would be 1 upon 4 pi epsilon naught 2Q. Now what is the distance of this 2Q from here? Certainly if this value here is L by root 2 and this would be 45 degrees, so I can say this will also be L by root 2 as this is the perpendicular. So putting the values L by root 2 whole square, I will get 1 upon 4 pi epsilon naught 4Q by L square. This is the third option. So I have 3 here, 3 vectors here. So first question of mine was, which are the numbers in which the electric field due to these charges will be there? So this is 2 and 4. 2 and 4 are the numbers, the vectors which will coincide with the electric field due to these charges. Now, when you talk about the net electric field, you can see the value of this and this, that is plus Q and minus Q is same. So can it be considered E? If I consider this magnitude as E because they are same, I can say this will be 2E because it is double to that of L. So you can see the representation here that downwards is E, then E. They together will become what? 2E. This is the value. And this was also equal to 2E, so this is the value. As you can understand, the angle between these two vectors. This is 90 degree. So what is the resultant? Definitely it would be 2 root 2e. How we can find that? Let's see. If you want to find the E net, you will write under root of 2e whole square plus 2e whole square. That will give you 2 root 2e. Or I can write 1 upon 4 pi epsilon naught into 2q by L square into 2 root 2. This is the net electric field which I am talking about, and that would be equal to E net. This is 1 upon 4 pi epsilon naught 4 root 2q by L square, and which will be parallel to base. How can I say so? If you see this is 45 degree, then you see this is the line where the net electric field would be, that is E net, that is parallel to base, right? So I would say this net electric field, so this electric field will be in the direction of 3. So there are 3 numbers which you have to work. First is 2, on which the electric field due to plus 2q charge was there. Then is number 4, the electric field due to plus q and minus q was along to it. And the direction number 3 is the direction at which the net electric field is working on it. I hope you have understood the answer very well. Now let's try an advanced level question. So in this question you see a particle of mass m and charge q is suspended from point A with silk thread of length L. Another particle of charge minus q is fixed at a distance L from point A. You can see this is minus q, it is fixed at a distance L from point A. The charge q and point A are such that they are lying on a horizontal plane. So this minus charge q and A is lying on a horizontal plane, and the thread makes an angle 30 degree with the vertical. So this is the thread at which the mass is suspended. It is making angle 30 degree. We have to find the value of m and the tension in the thread. Now you can see the question, and let me just explain you a bit. This is the point A with the help of which this mass m is suspended. It is carrying a charge q having mass m, so weight is acting downwards, tension is this side, and this minus q is attracting it towards itself, so that is F. So definitely this is L, this is L, this is L, so this is an equilateral triangle. Certainly this would also be 60 degree and this will also be 60 degree, right? Now what is the force which is acting along this direction? So this is the force. We have to find the value of m in terms of q and L, and certainly we have to find the value of tension as well, right? Now let's start with the solution. First is, what is the value of F? By magnitude, it would be 1 upon 4 pi epsilon naught q square upon L square, right? Because it is acting like this. And then, if you want to talk about the tension, so first of all, understand this one, that this is 60 degree, this would be 150 degree, and this would be 150 degree, right? By Lami's theorem, I can write mg upon sine 60. That would be equal to T upon sine 150, and that is equals to F by sine 150, right? By this equation, I can say T is equals to F, that is equals to 1 upon 4 pi epsilon naught q square by L square. So I hope you have understood this portion very well, that why we came to this conclusion. Now we have to find the value of m. So with the similar equation, I can simply use mg by sine 60. Let me write that for you. Mg by sine 60 is equals to F upon sine 150. Now what are the values here? If you put, this is mg, sine 60 is root 3 by 2. This value is 1 by 4 pi epsilon naught q square by L square, and whole divided by this sine 150 is 1 by 2, right? So this and this will be cancelled. From here, if you want to find the value of m, you will be writing m is equals to 1 upon 4 pi epsilon naught, it will remain as it is, root 3 q square by g L square. This is the mass which we are talking about. So we have found both the value of tension and value of mass here very easily. Though it implied Though we use the method of force, but this was a good question which involves the application of mechanics as well as the electrostatics. And you will see these kind of cases in the exam. I hope you have understood the lecture. In the next lecture, we will be talking more in detail about the electric field lines and its properties and several other factors. Till then, stay tuned. Thank you. Hello everyone. Hi friends, I welcome you to the sixth lecture of electrostatics. In the last lecture, we have studied the details of electric field. Now, it's time to apply the concepts we have done there. We have understood the simple applications, but now let's step up ourselves and do the questions which are a little bit beyond the level of NCERT. Let's start with the very first question. Now here, an infinite number of charges, each equal to q, are placed along the axis at x equals to 1, x equals to 2, x equals to 4 and so on. We have to find the electric field at the charge q which is set at x equals to 0, that means at origin. And these set of charges are moving along positive x-axis, that means since they all are similar in nature, all of these charges will apply force towards negative x-axis. So one thing is certain, that the net electric field will be towards the negative x-axis or minus I cap, right? Now, if you talk about the solution here, this question simply lies to the section of superposition principle, but it involves a bit of mathematical application too. Don't you worry, I'll tell you what application is there. There's only a simple logic and I'll be defining that for you as well. Now let's start with step by step. We have the diagram for ourselves. This is the target charge. Now, other all charges will behave as a source charge. So, this is source charge 1, this is second, this is third, this is fourth, and so on. It will go till infinite. Now, what would be the electric field due to first charge? If you say it would be 1 upon 4 pi epsilon naught q upon, what is the value of x? That is 1 square, or I'll say 1 upon 4 pi epsilon naught q, right? Similarly, when you talk about E2, that is electric field due to second charge, it is 1 upon 4 pi epsilon naught q upon 2 square, or you will simply say 1 upon 4 pi epsilon naught q upon 4. This is nothing magical I am doing, I am just writing down the electric field due to individual charges. Let's say similar thing for 3, it will be, yes, you are correct, 1 pi 4 pi epsilon naught q upon 16. Why? Because the distance is 4 meters, the square of 4 is 16. And when you talk about E4, so that would be 1 upon 4 pi epsilon naught q upon 64. Now, let's take this as fourth equation, this as third equation, this as second equation, and this as first equation. Now, all the electric fields are directed towards negative x-axis. We have already discussed. So, all the electric field being in similar direction, they will be simply added. So, let's add them. I will write net electric field would be sum of all the electric fields plus En, or I'll just put on the values that by magnitude E net would be equal to E1 plus E2 plus E3 plus E4 till En, right? So if you just put on the values we have known so far, I'll take Q upon 4 pi epsilon naught as common. I will get 1 plus 1 by 4 plus 1 by 16 plus 1 by 64, and this will continue till infinity. Now this is a special kind of series known as geometric series. Now for this series we have a simplified solution. What is it? Let's see. In such cases where you have A plus AR plus AR square plus so on, this can be simplified as A upon 1 minus R. Now in here, this was A. And what is being repeated, if you understand, this is 1 by 4 power 0, this is 1 by 4 power 1, this is 1 by 4 power 2, this is 1 by 4 power 3, and so on. Things are changing. So what is the repetitive term R here? So from here, if you interpret R is equals to 1 by 4. So the term which you are seeing here, if I solve this one, I will get 1 divided by 1 minus 1 by 4, and this will be simply equals to 4 by 3, right? So in terms of this whole series, I can simply put 4 by 3 here. What I will get is E net is equals to Q upon 4 pi epsilon naught into 4 by 3 instead of whole series. And it is a mathematical application. Just stick to it, that what I have done here is I have taken this series, this formula, and measured or compared it with this one. I found that A is the common value which has been taken out, and what is the term which is repeated again and again is 1 by 4. And I put the value here and I get my formula that the whole series is equivalent to 4 by 3. So just putting down the values, I will get Q upon 3 pi epsilon naught. This is the net electric field, and this is along minus x axis. So if you want to write it in the direction of I cap, so you can write minus, let me write that for you as well. So that will be E net is equals to minus Q upon 3 pi epsilon naught I cap. So I hope you have understood this very easily, and this is the better representation, friends, because you don't have to write this every time. This gives you a clear indication that it is along the negative x-axis. The question was a simple format of superposition principle, but a mathematical formula was applied, and similar kind of questions will be coming to you in this lecture. We are just complicating the questions to the next level by introducing two concepts, one of the electric field or one from the mathematical, or the two concepts combined in the electric field question. Let's see our next question to have a better understanding. Now, here you see that there is an electric field. We have to calculate at point O due to this system of charge. Now, what is the system given here? There are two charges, plus Q and plus Q, which are separated on the either side of point O at a distance R. Now we'll go by simple method. This is a place where test charge will be kept. This is the first body and this is the second body, right? Now this and this being positive, test charge is always positive and this charge is positive in itself. It will apply electric field in this direction, that is E1. Similarly, this charge will apply electric field in this direction, which is E2, right? What would be the value of E1? It's very simple, friends. You can write E1 as 1 upon 4 pi epsilon naught capital Q upon R square. This would be the first equation, right? And the second value E2 would be again 1 upon 4 pi epsilon naught Q upon R square. That would be the second equation. as you can see at the point O, both the electric fields are in opposite direction. That means the net electric field will be simply subtraction of E1 and E2 as they are at 180 degree with each other, and the net electric field you will find is 0. Do remember this, because I have already told you a shortcut trick here. What? In the previous cases, we have understood the same thing for force, that whenever there is a symmetrical distribution across a point, in that case the net force on the point would be 0. So here the O charge is lying at the symmetrical center of the two charges. This is the main key point where you should directly come to the conclusion that net force here at O will be 0, right? Let's move ahead with a similar kind of question. Now in here you find a triangular lamina where at the three corners capital Q is placed, and we have to find the electric field at O. It's pretty obvious the electric field will be 0 here too. Now by what virtue am I saying so? Let's see. If you understand that this distance is x, certainly this will be x and this will be x also, because it's an equilateral triangle. Now if you think about the electric field that these charges will apply, this charge will apply electric field in this direction, this charge will apply electric field in this direction, and this is going to apply electric field in this direction. As you can understand, let's take this as E1, this as E2 and this as E3, because this was the first charge, this is the second charge, and this is the third charge. You can understand easily that this angle you are seeing is 120 degree, this also is 120 degree, and this also is 120 degree. When you see to the diagram, you will find that the value of E1 equals to E2 equals to E3 will be equal to 1 upon 4 pi epsilon naught Q upon x square. All the three electric fields are equal in magnitude. By Lami's theorem, when there are three electric fields which are satisfying an equation, what it is? Let's see. I'll write that equation for you. So in the case, a vector A divided by sine alpha, vector B divided by sine of beta, and vector C divided by sine of gamma. Where A, B, C and alpha, beta, gamma are, let me show you. So let's take this as one vector, this as other vector, and this as the third vector. So this being A, this being B, and this being C vector. Now this will be alpha, this will be beta, and this will be gamma. So if this relation is satisfied, remember A by sine alpha, vector A divided by sine of the angle opposite to that vector, vector B divided by sine of the angle opposite to this vector, and C divided by sine of this angle. In that case, you will find that if this is satisfied, it means the resultant of the vectors at this point will be 0, and we have proved this already in our previous class. I hope you remember that. So here also all the three electric fields are equal. All the three angles alpha, beta and gamma are equal. That means the ratio will be coming to equal. That means ratio of E1 by sine of 120 will be equal to E2 by sine 120 and E3 by sine 120. That means the net electric field at point O here will be 0. I hope you understood this one, right? So I have proved you mathematically and by the help of equations as well that this solution will be 0 here. Now let's move ahead and see some similar kind of questions. Now let's take the same question we have just solved in a different manner, because many times understanding Lami's theorem will be difficult. So I'll present the same question to you in a different manner so that you can understand it easily. And that section belongs to resolution of vectors. So now I will be solving the same question by the help of resolution of vectors. We will get back to again same concept that the electric field due to these charges will be. Due to this charge it will be like this. Due to this charge it will be like this. And due to this charge it will be like this. And this time we all are well aware that electric field would be E. That is same. What would be the value of electric field? It would be small k capital Q upon x square. What is the value of x here? So this is the value of x, right? So all the three. Now if you want to understand that how to apply the resolution of vectors, you must understand that there should be coordinates in order to resolve the vector. So you need to have x and y axis, and whichever vector is not lying on the axis, it has to be resolved, right? So let's draw the x and y axis as per our understanding. So let's take this as y axis, right? And let's take this as x axis. So we have x and y axis. Let's take this as x and this be y. Now what is the angle between this and this? That would be 30 degree. What is the angle here? Again, of course it would be 30 degree. And this angle is 90. We are well aware of this, right? Now you need to do the resolution part. I'll draw a simplified easy diagram for you here. Let's take again that this be the x-axis, this be y-axis, and you have some vectors like this is the electric field in this direction, this is the electric field in this direction, and one electric field is going straight down, right? Now all of them were E, and E, and this angle was 30 degree. We have already discussed. I think you are clear with this concept. This is y and this is x. Now which vector do you find not lying along x and y axis? Obviously these two. Now let's resolve this one. So it will be along this direction, that is E cos of 30 degree, and above direction it would be E sin 30, right? Similarly, if you talk about this one, it would be along this direction. This is E cos of 30. I am using a different pen because here it will be clumsy, and upwards would be E sin of 30. This has moved a bit upward, but it's straight, right? Now, if you see that I have resolved the vectors along x and y axis, now finally I am left with 5 vectors. Which are those 5? 1, 2, 3, 4 and 5. Let me highlight them for you. 1, 2, 3, 4 and 5. Out of these, along y-axis there are 3 vectors. E sin theta and E. And along x-axis there are 2 vectors. E cos theta and E cos theta, opposite direction. Now let's have the vectorial sum along x-axis. When you come to this one, it's quite obvious that net electric field along x-axis would be 0. Why so? Both the electric fields are equal in magnitude and opposite in direction. So obviously that is coming to be 0. Now when you talk about y-axis, so this is the positive x-axis, so E sin 30 plus E sin 30, and this is the negative y-axis, so this is minus E. Just add them vectorially, and along y-axis what I will get is Ey is equals to E sin 30 plus E sin 30 minus E. So thus when you solve this, you will get E by 2 plus E by 2 minus E, and you will find that Ey here would be 0. So this is the second equation, and this being the first equation, you can see both the x and y components are 0. That means the net electric field at point O will be 0. So same thing we have proved with the help of Lami's theorem, and same I have done by the vectorial method as well. Later on, I will not use this method again and again. Wherever I will find the Lami's theorem application, I will just tell you, and you can apply the similar concept of vector resolution for all the complex cases. The pattern is exactly same. You make x and y axes and resolve all those vectors which are not lying on x axis or y axis. I hope you have understood this one. Let's take another case. Now, in here, a similar question, but now it's a square. So, it's quite easy to solve. Why so? If you take, let's take this as first body, this as second, this is third, and this is fourth. By our understanding, we should not solve this straight away. We should say that this electric field at point O will be 0. But let's take our chances. Let's start solving it. So when you start solving it, you will find that electric field due to first charge will be along this line. Electric field due to second charge will be along this line. Electric field due to third charge will be along this line. And electric field due to fourth charge will be along this line. Let me write that for you. This would be E1. This would be E2. This would be E4. And this would be E3. And I tell you one thing, that this distance would be x, that is this half of the diagonal. What would be the value of x? That would be a upon root 2. So when you want to find the value of E1, E2, E3, E4, let's write it for E1. It would be 1 upon 4 pi epsilon naught capital Q upon x square. On simplifying, you will get 1 upon 2 pi epsilon naught Q upon a square. Right? I have just put the value of x here. You will find that E1 value is equal to E2 is equals to E3, and that is equals to E4. You can find it, and that would be Q upon 2 pi epsilon naught a square. So all the electric fields are equal. That means it's very simple that if I take the direction of x-axis and y-axis, you might be astonished that why am I taking so? Because it's my free will. I can take these axes as I want. It's only that x and y should be perpendicular. And you will find that E4 and E2 are lying on the x-axis, but they will cancel out each other because they are equal in magnitude. And similar for E3 and E1, they are lying along y-axis and they are equal and opposite to each other. So again in this case, friends, you will find that Ex is 0 and Ey is 0, because this was E as per the diagram. You will see here E4 minus E2, and this is E3 minus E1. Right? So again, by symmetry, the electric field at O is 0. I hope you have understood this one very easily. Let's move ahead. Now when you see this one, it seems to be a dangerous question. There's too lot of charges. But open your eyes and see it. Frankly speaking, it's a very easy question. It's following symmetry at every axis. So certainly the answer should be 0. You want me to solve it? I'll better say pause your screen, solve it by yourself, and I'll follow you. Yes, now let's see. I hope you have got this answer as 0. I'll solve this one for you. You will say that the charges, let's name them 1, 2, 3, 4, 5, 6. This is an hexagon. So this would be 60 degree, right? Both the sides are equal. So this will be also same. So this would be 60 degree also. So you can see this is an equilateral triangle. So what is the dimension of this side is A. This would be A and this would be A. So you know it well that this will be A from all sides. Now, when you talk about the electric field, right? When you see for first charge, the electric field will be along this direction. For second, the electric field will be along this direction. For third, electric field will be along this direction. For fourth charge, the electric field will be along this direction, right? And for the sixth charge, the electric field will be along fifth and sixth, right? And all the electric field will be equal to 1 upon 4 pi epsilon naught q upon a square. All of them will be equal. So let's write that value. This is E, 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 and this is E. You can see all the electric fields are cancelling out each other. So what would be the net electric field here? Would be 0. Again, symmetry has proved our concept. Now let's take a last question of this sort. This is the case, pentagon. Is it symmetrical? Yes, it is. Not on all axes, but it follows a symmetry on a central line. In that case, Lami's theorem will help you. You can also go by the help of resolution of vectors, but that will definitely haunt you, because in that case you will have to remember the cos and the sine value of unknown degrees. I would request you to follow the Lami's theorem here. Let's see how we can apply Lami's theorem. You can understand that this is first charge, this is the second charge, this is the third, this is fourth, and this is fifth charge. All of them are applying electric field in this manner. Let's say the first charge will apply electric field straight downwards. The second charge will apply the electric field in this direction. Third charge will be applying the electric field in this direction. Fourth in this direction. And the fifth one will be applying electric field in this direction. And remember, this value will be x, this will also be x, this is x, and this is x, and this is x. You can solve this by help of symmetry. All the value of inner lengths will be x. Now, by this I know that this is the electric field E, this is E, this is E, this is E, and this is E. Now let's talk about the degrees. If you talk about the degrees, you will know that this would be 72 degree, right? That is 360 divided by 5, and every angle is 72 degree here. That means the angle between every two electric fields is 72 degrees. That means every time a vector divided by the sine of the angle opposite to that will be E upon sine of 72, and in every case it is coming to be equal. That means the electric field at point O will be 0. Right? So we have understood that in all the cases of symmetry, you pick your ears by one method or by the other, you will get the electric field to be 0. I hope you have understood all the applications in such cases. Now it's time to understand the same logic with a different numerical. Let's move ahead for the next case. So friends, many a times in exam it happens that you see a question and you pound on it. You say that this question is known to me, and you will see that the first option is the option you remember, and you take it. When you come out of the exam, you will remember that you have missed an important information, and due to that you have marked that question incorrectly. So let's have some of the misleading questions like this one you are seeing. We have just solved the question like this, and we say that the electric field at center would be 0. But remember one thing, there is no charge present here. That means this case has lost its symmetry. Now in that case, what will be the electric field? So we have to solve it separately. Like, let's take this as first charge and this as the second charge, and we want to find the electric field here. We will say that electric field due to first charge will be like this, and electric field due to second charge will be like this. What is the angle between them? It would be 120 degree. So if I know the value of x, I can find the electric field. Let's take this as E1 and this as E2. Let's start with the solution. Now with this, the question becomes a very different one, right? If you say E1, that would be 1 upon 4 pi epsilon naught q upon x square. Now what would be the value of x? Certainly, this distance you see is A by 2, and this angle is 30 degree. So it's very easy to write cos of 30 would be base upon hypotenuse. So x would be A by 2 divided by cos of 30. Now what's the value of cos 30? That is root 3 by 2. So it will go A by 2 divided by root 3 by 2. Solving this one, you will get x as A upon root 3. This is an important observation which we will be using again and again. Putting this value x here in this equation 1, I'll get E1 as E1 equals to Q upon 4 pi epsilon naught into 1 upon A by root 3 whole square. You will get 3Q upon 4 pi epsilon naught A square for E1. And let's take this as equation 2. When you solve this for E2, what is the distance x? So you will find that E2 will also be exactly same. This is 3Q upon 4 pi epsilon naught A square. Let's take this as equation 3. So I have two vectors which are equal in magnitude. May I say that from equation 2 and 3, E1 and E2 are equal in magnitude. Let's name them as E. And I have two vectors, that is E and E, which are at angle of 120 degree with each other. That means the resultant here, friends, will be exactly same as that of the vectors. This I hope you remember, but if you have not remembered it, I'll solve it for you. The resultant R. The formula we have for R is 2E cos of theta by 2. So that is 2E cos of 120 by 2, that is cos 60, and cos 60 is half. Solving this, you will get E. That means the resultant will be 3Q upon 4 pi epsilon naught A square. This is the pretty simple application you have to understand. But this question was pretty big one. I have a shortcut trick for you. The same question can be solved by the help of a shortcut trick. What it is? Let's go back to the question. In this question, you find that resultant electric field is here, and it was similar to this value of E. Let's replace this plus Q charge here. Same charge. What could have been the case? That this could have applied the electric field in this direction, which could have been E. And due to this charge, the net electric field at O would have been 0. Why so? Because this electric field would have cancelled this resultant will be equivalent to E. That means bringing the third charge plus Q here, which was equal to these charges, it resulted in 0 electric field. So I'll have another theory. If I remove this charge, the whole system will apply the same electric field as this charge was applying at this point. So you will say whatever electric field this charge would have been applied on this point, both these charges will apply same electric field but in opposite direction to that of the electric field applied by this charge. So it's very easy to find the electric field due to one charge, and this system will apply the same electric field by magnitude on this point but in direction opposite to whatever electric field this could have applied on the center. So you will get the resultant as it is. You don't have to do the vectorial addition. Let's apply the same concept in our next question. So you see here a similar kind of case where there are three charges, the fourth one is missing. So here I will not use the vectorial addition, I'll go by other method, that I'll take plus Q here. Now it's very simple. Let's take this as X. So this could have been X also. This will be X and this will be X. What is the electric field this charge will apply on O? So it will be applied upward direction, and that electric field will be Q. upon 4 pi epsilon naught x square. What is the value of x? That would be a by root 2. If you put it there, you will get electric field E as q upon 4 pi epsilon naught a square into 2, or q upon 2 pi epsilon naught a square. This is the electric field which is applied by this charge at the center point. So I'll say if I remove this charge, the whole system will apply electric field exactly equal to this electric field, but in direction opposite to it in this direction. And what is the electric field applied by this system? This would be E, which we already know the value would be Q upon 2 pi epsilon naught A square. So instead of calculating the electric field due to all the other three charges, what I did, I placed the plus Q charge there, which resulted into zero electric field here, and I calculated the electric field applied by this charge, which is going upwards, and the whole system will apply the electric field equal to this electric field but in exactly opposite direction. I hope you have understood this one. Now let's move on to our next question to understand this on a better scale. Similarly, you find here, so as hexagon we have understood that this would be A as well, this would be A as well, A. And if I place the plus Q charge here, which was missing, the electric field at this point would be 0. Now, the plus Q charge would have applied the electric field at O to be Q upon 4 pi epsilon naught A square, which could have been upwards, right? But since it is not there, so whole of the charge system will apply the same electric field but in downward direction, which will be having the value E only, but opposite to that of the charge plus Q would have applied. So I have used the concept of symmetry. Whenever I found there is absence in symmetry, I will try to cover it up with one charge, which is equal to the charge which is surrounded. And I'll find that the center point electric field will be 0. And thus I'll say if this charge would not have been there, the whole charges would have applied the same electric field here in downward direction. I hope you have understood this section very well. Now let's move on with different kind of numericals. So friends, let's take our next question. Center as origin. So friends, let's take our next question. This question is a different kind of question we have seen till now. Now this question has been famous in NEET exams and it has been asked with various aspects. So I'll tell you this question in detail and step by step. Don't worry, there will be much of the mathematical calculations, but as of now I have been teaching you every step in detail, so we will follow the same method here as well. And just practice this question twice and you will remember this concept for your whole life. Believe me. Let's study the question. There are 2 point charges Q are placed at a comma 0 and minus a comma 0. That means they are placed, let's take the center as origin, and one is placed at a comma 0 and the other as minus a comma 0, right? Both the charges are equal in magnitude. We have to draw a graph to show the variation of electric field strength on 2 parts, one being along y-axis with distance y from the origin and one along x-axis with distance x from the origin, right? So let's take the very first part here. I want to show you the variation of y-axis first, that's the lengthier one. Now for y-axis, if you see, let's imagine some point here P. So what would be the electric field? The electric field due to this charge will be in this direction and electric field due to this charge will be in this direction. Let's see that. I have made this for you. So you can find that due to first charge, the electric field is in this direction, and due to second charge, electric field is in this direction, where this is E1 and this is E2, right? When you see that what is this distance, so this being y, this is a, so it will be a square plus y square. So what would be the value of E2? If you understand well, the value of E2 will be simply so E1 would be 1 by 4 pi epsilon naught q upon under root of a square plus y square whole square. Why so? Because the distance between the q and this point is this. Putting the values, you will get E1 as 1 upon 4 pi epsilon naught q. This value would be a square plus y square. And also the value of E2 will be same. Why is it same? Because the same charge, same distance as a square plus y square is here also. So E1, E2 both will be the same in magnitude. Let's term them as E dash, right? So definitely E will be written as 2 E dash cos of theta. As you are well aware that the two vectors are at the angle of 2 theta now, right? So on solving this, you will get 2E dash cos theta. Let's put down the values. I will say E is equals to 2 into the magnitude of Q upon 4 pi epsilon naught a square plus y square into cos of theta. So let's understand here that this theta is base would be y and hypotenuse would be this, that is a square plus y square root over. So let's put down this value of cos theta. You will get E as 2q upon 4 pi epsilon naught a square plus y square into y upon root over of a square plus y square. Now the twist starts. If you just simplify this one, you will get q y upon 2 pi epsilon naught a square plus y square power 3 by 2. And this is power 1 and this is half, so it will be 3 by 2. You have the electric field at this point y, right? Now, if you understand that at this particular point, the variation of electric field with y is given by this expression. If I want to find the maximum value of electric field with respect to y, I need to differentiate this electric field with respect to y and equate this result to 0. Because differential of any maximum quantity would be 0. We have already understood this in our previous class. So, when you solve this one, just differentiating it with respect to y, what will happen? This q 2 pi epsilon naught is constant, it will come out and you will write d by dy of, I can write this as into this term, a square plus y square minus 3 by 2. This is a into b format, right? Now I'll say for E to be maximum, dE by dy at this given point is 0, right? So on solving this, let's put on the values. So I'll say this to be 0. 0 would be equal to q upon 2 pi epsilon naught. Now this is a into b format, which will be written as a into differential of b a square y square minus 3 by 2, right? Plus b into, let's write b, so that would be a square plus y square power minus 3 by 2 into differential of a. It's very simple. You can also proceed as per the inverse of that. That is, you can use the division theorem as well here. You just let it be at the downstairs, but it would be quite complicated. That's why I put the denominator in upstairs, that is in the place of numerator, in this negative format. It will simplify our calculations. So let's move on, and here you say that 0 is equals to, I'm moving this portion on the left hand side, and I'll get y into, what is the differential of this portion? That would be, this will come minus 3 by 2 into a square plus y square minus 3 by 2 minus 1. Now, this is a simple format. This is a complex number. On differentiation, I'll have to treat it as a function. And this function is raised to some power. So, on differentiating it, this power will come in front, then the function, then n minus 1 term, right? Since it's a complex function, that is, the variable is included here, I'll again differentiate this function with respect to y. I hope you remember this one. So, this part of differential is over. Not talking about this part, let's write it here, plus this a square plus y square power minus 3 by 2 into 1. y1, dy by dy would be 1. On simplifying it, what you will get from here is 0 equals to y. This would be minus 3 by 2 a square plus y square. This is minus 3 by 2 minus 1. This is minus 5 by 2 into differential of a square would be 0 plus differential of y square would be 2y, right? And plus you will get a square plus y square minus 3 by 2. Now let's bring this portion here. This negative sign will become positive, and you will get from here as 3y square a square plus y square minus 5 by 2 would be equal to a square plus y square minus 3 by 2. On simplifying, 3y square equals to a square plus y square. This is minus 3 by 2 plus 5 by 2. On simplifying, you will get y equals to a by root 2. This is an important observation, friends. You must remember, always, in such cases of maximum electric field, the y will be equal to 1 by root 2 times the distance of the symmetrical charge distribution from center, right? And now the point of graph. So if you see here, this equation will tell you that starting the value y equals to 0. So if it is 0, the electric field will be 0. When you increase the value of y, the y will increase up to a certain extent, and then it will start decreasing, because when y is equals to a by root 2, the value would be maximum. What would be the value? We need to find that, and after that what will happen? It will come down. So this graph will definitely be a curve portion, and you can see here I have made it for you at this point, that is at origin. The value was 0. Till the part of a by root 2, it grew up to maximum. For the maximum value, let's mark this as this. Let's try this to be E0. So we need to find the value of E0, and later on it will decrease, and after infinity it will become 0. So there are phases before coming to maximum and after coming to maximum. So before coming to maximum, it will raise, it will become a maximum, and then it will drop down and it will become 0 at infinity. I hope you have understood this one. Now what is the value of E0? So that will be Q y upon 2 pi epsilon naught a square plus y square power 3 by 2. Let's put the value of y there, that is a by root 2. You will get Q to a by root 2. divided by 2 pi epsilon naught a square plus this is a square by 2, this is power 3 by 2. On solving, this is q upon 3 root 3 pi epsilon naught a square. This is the value of E naught, right? This is the maximum electric field we could have find at that given point. So 3 important highlights. 1. At y equals to a by root 2 will be the maximum electric field. 2. The graph will be in a curved portion. It will rise from 0 to E naught at the position of a by root 2, and then it will drop down and it will be 0 at infinity. And the third is, this is the value of maximum electric field possible in this case. I hope you have understood this part. Now let's move on to the second part of this question. Now let's take the second part of this question. In this second part, we need to see the variation along x-axis. For a moment, just forget about the second charge. Just think from one charge point of view. The electric field, we have already understood that it would be in a hyperbolic manner, where the electric field will not cut the y-axis and x-axis. I hope you remember from the previous lecture. And similarly, if you see due to this charge, it will be a similar case when you're talking about point along positive x-axis. When the point is along negative x-axis, the graph will be on the opposite side. Yes, you are right. And you will see that this will be the diagram for same. That when the two charges are situated at these points Q and Q, on the point which is beyond the charges along positive x-axis, the electric field will form this shape, and on the point this, it will form this shape. The value will be different from a single charge, but it will form this shape only. We will see the calculations as well. But let me simplify this for you. This is already what we have understood. Now the point lies in between. But obvious, when you talk about this point at center, here electric field will be 0. Right? How so? Because it's a symmetry. That means at the center point, the electric field will be 0. When you talk about the point which is very close on the surface of Q, in that case, the electric field due to this charge will be maximum. It will be infinite because R is 0 for that case. So electric field, which is in this direction and maximum, will be marked somewhere here. And the graph will start like this, right? And this graph will merge with this point like in this manner. Similarly, when you talk about this point here at the surface of this charge, you will find that at surface of this charge, again R will be 0 for this, and the electric field due to this charge will be too huge, and it will be in the positive x-axis. That electric field will start from here, and it will be parallel to y-axis, and it will merge like this here. So the final version is, when you move from here to here, the electric field will decrease. It will come to 0 at the center. And then from here to here, when you go, the electric field will increase, but in opposite direction. So I have drawn this simple format for you to understand this is the answer. Right? If you want to have the calculations, you can always do the calculation. There will be two cases. Let's take as case 1. So let's take for case 1 the point P here, that this distance is x as shown. So the distance here, if I say, would be x minus a. And the distance from here to here would be x plus a. That would be case 1. On solving it, you will get case 1. E would be equal to 1 upon 4 pi epsilon naught q upon x minus a whole square. This would be the electric field due to the first charge, which is along this side. And for this charge, electric field along will be on this side, but now the distance would become x plus a. So I am writing here plus. I'll take 1 by 4 pi epsilon naught as common. I'll get q upon x plus a whole square. You take this as common, so net electric field here, E net, would be q upon 4 pi epsilon naught. On solving this, you will get x square minus a square whole square, and that is x square plus a square into 2. And that's a complex equation you will find with respect to graph, but still you will get an idea that the parabolic shape was there because of this equation. You don't need to solve it further, but still you have a case, and if you have a value of x and a related, you can find the value of E net. Similarly, for case 2, if you say, let's take case 2 at some random point here. In that case, x will be this one. And then you can have the values which will cancel out each other. Now at this point, let's say Z. Electric field due to this charge will be along this direction. And electric field due to this charge will be in this direction. Right? In that case, this distance will become x plus a, and this distance will become x minus a. And the calculations, you just have a similar format, but the negative sign will come here. Let me write that for you. So case 2, that E net would be q by 4 pi epsilon naught, I am taking as common. So 1 upon x minus a whole square. Because the denominator will be smaller, definitely the value will be higher, minus of 1 upon x plus a whole square. Because both the electric fields are opposite. On solving this, you will get q upon 4 pi epsilon naught. This would be x plus a whole square minus x minus a whole square. And this whole should be divided as x square minus a square whole square. On solving, you will get q into 4xa whole divided by 4 pi epsilon naught x square minus a square whole square. This is the net electric field in case 2. Now you put x is equals to 0. What will be the value of electric field? 0. When you put x is equals to a, you will find electric field would be infinite. So this is what I was showing you, that when x is equals to 0, electric field will be 0. When x is equals to a, the electric field would be infinity. And the case beyond the charges is already known to you. So we have understood that what happens along y-axis and what happens along x-axis, and we have included all the in-depth variations of electric field for the two positively charged system. In the next lecture, we will be dealing with some more of numericals along with the concept of neutral point. So hope this was useful to you. Let's meet in the next lecture. Till then, take care. Bye-bye.